Welcome, and if you recollect, we have discussed all the the features of green building, a number of them, also related to sustainable materials. Now, in this lecture or set of lectures, we should discuss the design strategies and the green design process. So, let us look at greenhouse gas emission, recollect some of them. We have seen that if you look at this one, basically transportation sector around 28%, buildings around 40% and industry around 32%. So, building sector is one of the major source for emission of greenhouse gases. And if you look at the other feature, that is energy consumption, you will see that in the building themselves, commercial buildings, space conditioning, that is very high, while in case of residential, space conditioning is relatively low. But lighting, you see that for residential, lighting is relatively high and space conditioning is very less. This is an Indian scenario, right, and obviously others is something like this. So, energy, we have seen greenhouse gas emission and the energy consumption, and you recollect that these are major features related to green concepts. We like to minimize the energy consumption and obviously the greenhouse gas emission as well. Then, if you see the distribution in a building, which you have seen earlier in a different form of a graph, you will find during the life cycle operational energy is the maximum. Embodied energy and other gray energy etc., is something of this order 2.5 to 12.5 to 18.5% and this is about 77 to 83%, and demolition and recycle energy, that will be coming somewhere there, small percentage. So, this we had given in a different form of curve before. So, based on these issues and the other we have discussed earlier, sustainability requirements are, these are the sustainability requirements: minimize pollution, obviously this is one of them, energy consumption, minimize that, maximize the efficiency of building materials, efficient building system, of course, that will make it, and healthy building environment, and obviously life cycle should be as high as service life should be as high as possible. So, these features are actually to see the performance of the building, green performance of the building. Tools have been, some tools have been are available, which we shall discuss later on. These tools looks into several criteria like site selection, many of them, there are different tools, some of them I will mention today, some maybe later. Energy efficiency, water efficiency, because minimization of the resource consumption, material efficiency, that is what I was talking of, minimization of the resource actually again, and indoor air quality, we discussed it earlier, and waste and pollution, economics, operation and management, etc. These are the features. So, some of the tools actually looks into this one. Now, let us denote them as C1, C2, C3, etc., etc. These are the criteria, criterion C1, criterion C2, etc., etc. So, there are different criteria that could be there, right, by various this criteria could be there, right, and yeah, this is actually 8 of them, not this is 5, 6, 7, 8. So, 8 of them are there. So, this could be various, or there could be more of them, or less of them depending upon the tool that you are using. So, all these tools that we will discuss a little bit later, name them, some of them, there are a number of them available in it now. For example, lead is one of them. In India, Griha is used. There are several others which different countries uses different tools. All of them, what they do is they try to judge the building according to this criteria, right. And most of them, there is a mandatory requirement, there is a minimum level. If that is not satisfied, the performance is not rated at all, because rating is not worthwhile. So, minimum criteria, minimum mandatory certain requirements are to be satisfied. Then for let us say a given criteria, levels of requirements are given in each of these tools, each of these tools, and these requirements are R11, R12, let us say requirements for criteria 1 is R1 and R2, there are several requirements are stated. And similarly for criteria 2, it could be R21, R22, etc. Just for the purpose of our understanding. If one building satisfies the R11 requirement, it gets a score of S11. If it satisfies R12, then it gets the score of S12. Similarly, if it satisfies, let us say Cn, right, some nth criteria Cn, and its correspondingly we will have R1, R n, let us say n p it satisfies, right, then it gets score corresponding to n p, scores corresponding to n p. So, requirements are specified, they are given, and a building is judged on those basis of its requirements. So, it will get clear when we look later on into any one of these examples. Let us say we have an example for lead, right. When we look into that, this will get cleared. So, for criteria 1, if it satisfies R1 j, let us say, then the score will be S1 j. So, scores are corresponding to each requirements, scores are specified, right. Scores are specified, and so for a given building, if the status is let us say R1, R2, etc., with respect to criteria C1, C2, etc. So, the status, so R1 should satisfy R11, R12, R13, etc., some one of those values, or correspondingly it will get S, S values, that is the score values it will get. Similarly, R, like something like Rn should satisfy, Rn1 or Rn2, etc., somewhere it should satisfy. Supposing it satisfies Rnp, then its score is S1p. So, scores are given depending upon what it satisfied, which requirement range it satisfies. So, this is the methodology in general adopted by most of the tools. If R1 satisfy R11, score is S11, or else if R1 satisfies R12, score is S12, or else, etc., etc. So, it goes on, and if it does not satisfy even the minimum requirement, the score is anyway 0. A mandatory requirement, if it does not satisfy, the basis will not consider even the same thing. So, similarly for R2, S2m, let us say in general, SJK, I can say in general, where J stands for the jth criteria, K is the satisfaction of the requirement level. So, score comes like this, and maximum score, first of all, maximum score possible is given by max of S11, 1, 2, etc., 1n, max of 2, 1, 2m, etc., etc. So, all the C, this is corresponding to C1, this corresponding to criteria C2, this corresponding to C for all criteria. So, Cn, if n total n criteria is there, so up to Cn. So, all the maximum values, that when I sum up, maximum value when I sum up, that is the maximum score possible. Now, the attained score, total score would be sum of Sij value that I have accumulated. For example, for the criteria 1, I might have got S1 some j. For this one, let us say S2L and S3Q and so on. So, sum all of them up as earned and for all criteria, and that is your total score for the building itself, right. Total score is the. Now, given the total score, if the total score is greater than some value B1, let us say, score is greater than B1, let us say, then rating will be X. The rating is given in terms of some quantitative or qualitative values, like some sort of rating in terms of gold rating, platinum rating, etc., silver rating, or some qualitative terms, or else. So, if it is greater than V1, rating is X, or else if the rating is greater than V2, the rating is Y, or else, etc., etc. So, basically, it's a if or else kind of thing. If you satisfy a particular type of rating value, then you total score is greater than a particular value, then you get a rating. This will be in qualitative terms, maybe qualitative terms, etc., and this is also in qualitative terms, so you get qualitative rating. So, that is how most of the tool works. Maximum values vary from tool to tool, criteria also are not same. So, if I compare all the tools, values are not same, criteria is also not same, right. So, let us say different evaluation schemes or these tools. So, there are various tools, for example, something called leadership in energy and environmental design, right. Some of them will be talking about this. So, IGBC is Indian Green Building, GRIHA is from the Tata Energy Research, TERI. There are several other tools which we will be talking about, BREEAM, and this will mention later on somewhere. And if you see this, these are each one of them is a different tool, and the points is if you see this, for example, weightages, this gives maximum to 37 to energy efficiency, while this gives 20 to energy efficiency, relative 18, 21, 32, 25. So, it varies. While site selection, this is 15, this is 15, this is 9, 8, 23, 10, etc., etc. And you go to water efficiency, material and resources. So, the criteria, of course, criteria themselves vary, and some cases this criteria may not be there, there is 0, there is simply not there. This one, for example, indoor air quality, this GB tool does not consider itself, and so on, but at the same time the weightage or importance given to it is also different, which is this importance is given by this course, by these values which are given here, right. So, the varies from. So, for example, if you look LEED and GRIHA, LEED we will discuss this again later on, each LEED will discuss one example of one specific case of LEED. Of course, it keeps on changing, but the basic structure would be explained by our by the next lecture when we talk about. So, indoor air quality LEED has got 7.5%, site selection 10.8%, energy efficiency 25.3. Now, this percentage is calculated from this, because 37 out of the total that you get would give us a percentage. So, when we work it out in this percentage, I get 25.3% water efficiency and so on and so forth. Whereas, if you go to GRIHA, site selection is pretty high, energy efficiency is 32%, its energy efficiency is somewhat, it is different. So, the point that I am trying to make is it varies from tool to tool, the importance given to this criteria and also criteria themselves vary. So, if I see number of them, if I compare about 6-7 of them which are used worldwide various places, as we shall mention in the some other lecture, the mean percentage variation in case of energy efficiency it is around 25, while a standard deviation is also calculated out, it comes out to be somewhat there, right, around 5%. Sustainable site average is around 12-13%, and water efficiency is around 15% and so on. So, there is a variation, this shows us the variation. Indoor air quality. So, while majority gives energy efficiency a major importance, right, but there is a variation, not everyone looks at every tool looks in a similar manner, because they are for different countries, and they are based on subjective decision of in kind of subjective decisions are also converted into objective form using various kind of managerial tools like analytical hierarchy tool and similar sort of thing, AHP as it is called, analytical hierarchy process. So, using this kind of tool, so experts view have been taken into account in this ones, and that varies from each of the tool to another tool, one tool to the another, and that is how it is, right. So, this gives us some idea. So, if I see comparison, global building sustainability evaluation tools, the references are also mentioned there. None of them deals with life cycle based work, most of them do not work with life cycle based works, and all of them are consensus based weightages. Building evaluation tool, consensus based weightages, and several of them, basically most of them are these are the people who they suggest, the literature would tell you that nobody looks at LCA, life cycle scenario, and also most of the people, there is a difference in tools and all. So, this is a summary of finding various authors, their comments essentially, right. So, that is it. So, weight percentage is a summary of what is the observations you can find by looking at all the tools together. Weight percentile varies from tool to tool, there is a deviation 5 to 9% of and benchmarking is done arbitrarily based on consensus of people. Well, you may say it is arbitrary, but not exact, somewhat it is based on subjective decision making. Building life analysis is relatively most of the people do not consider, and totality of building performance, everything cannot be considered, and that is not considered. So, these are the summary of different tools that would be there, and we will look into the tools in the next lecture, but let us look into some other strategies, conventional and green building delivery system. So, this is what the various tools which we will discuss sometime later on, at least one of them in some manner, because this may change and there are changes possible from time to time. So, one of the typical example of a tool, rating calculations or procedure we will look into in one of the lectures. Lead rating, for example, calculation we will take into one of the lectures later. But general green building strategy we can look into. Basically, essentially the strategy should be you reduce human exposure to hazardous material, maximum use of renewable energy, non-renewable energy and scarce material should be conserved. Water efficiency should be used efficiently, energy efficiency, local air, water, soils, flora and fauna should be they should be protected, and is transportation less energy. So, bicycle use could be maximized, minimize material impact on employing green products. So, these are the strategies as we can understand through our discussions. For example, we looked into the volatile organic compound emissions in buildings, renewable energy, so use of solar energy for example, and minimize the energy, so maximize the energy efficiency and so on, which we have looked into earlier sometime. Majority of the conventionally designed buildings have negative impact on environment, majority, because this was not a concern. So, obviously, we would have had some sort of negative impact towards occupants' health and productivity. This thermal comfort, acoustic comforts, that has not been looked in as much as importance they should be getting, including health issues. Also, these buildings are expensive to maintain and operate, because if it is energy efficiency, if it is not, if the envelope is not designed optimally, you will always end up consuming more energy than actually required, consuming more energy than actually required, right. So, to operate and maintain. Okay. The contribute excessive, and obviously resource consumption will be high, resource consumption will be high. So, since if it is optimally designed, you can minimize the resource consumption. Clear design objectives are critical to any project success. Yet to achieve maximum benefit, the project goals must be identified, right, and held in proper balance during the design process. So, first in this beginning of this lecture, we looked into how we judge the performance and how to achieve this performance. This is the strategy that we are looking of, right. So, the clear design objectives, first I must clearly state my objective. What is my objective? Design objective should be stated and get the maximum benefit to attain these project goals, right. If I identify them early and basically hold on during the project execution and design process, then it can be successful. Another feature of course is smart growth, what is called, it relates to ability to control sprawl, reuse existing infrastructure and create walkable neighborhoods. So, basically control is important and reuse as much as possible if you are changing anything, right. And it also relates to neighborhoods which will actually promote less use of mechanized vehicle which consumes energy. Obviously, fossil fuel energy would be avoided much. Now, neighborhoods are basically in planning, neighborhoods are basic units of urban plan, urban residential plans. And if it goes back to early development, where primary school was actually put into the focal point of neighborhoods, and children are expected to travel from their home to the neighborhood, right. No thorough traffic through the neighborhood, major traffic or arteries would be in the boundaries of the neighborhood, and internal roads will be meant for light vehicular traffic, which only the local vehicles in the neighborhood, they will be using this. Normally supposed to be matching with the topography and thereby giving a good look, and other issues of neighborhood planning is definitely there. Possibility of firefighting vehicle coming in and taking easy turn and things like that. So, those issues are there. So, basically this should promote those concepts, and that would be smart growth essentially. So, controlling the whole thing. Then integrated design approach, right. So, this differs from basically conventional design process on a number of ways. For example, the owner takes on more direct role in the process and architects takes on the role of team leader rather than sole decision maker. So, it is a group of people who should be taking design decisions, right, not individuals, and the role of the owner is very important here, all right. So, basically the group should be taking, the planner or the architect might take a lead role, but they are not, should not be the sole decision maker of the whole thing. So, this is the kind of process in integrated design process. So, if you want to ensure successes of any of such design, then strategies that would be important is establish a vision. that looks into, or that essentially embraces sustainability, right. Principles, sustainability principles are taken care of, such that they can be applied and integrated in the design process themselves. Clear statement of requirement of the project, objective of the design, and criteria and priorities in the design. So, obviously, it has to be economic, and therefore, the budget is to be looked into, and performance goals for energy, water, material, siting, indoor environment quality, along with other sustainable design goals should be it should be established, right. So, this should be established right at the beginning. So, this is a integrated design process can actually is a good strategy for green design system. It must take care of all those things, and your sustainability goals should be specified in the beginning, and the team should be working onto it, and followed by vision, establishing vision, and then stating them clearly, develop them, and obviously has to be economical. So, this integrated design process actually can incorporate building information modeling, which is there is software available for this, and virtual model one can create. So, to using software one can create virtual models. So, BIM actually helps in sustainable design, because you can see the virtual model, 3-dimensional models, and as with time variant scenario you can see, visualize different possibilities. Form a design and construction team that is committed to the project vision of QA, obviously that has to be there, and the contract document should actually follow the project schedule, and all this can be done to building information modeling. So, develop contract plans and specifications, and such specifications should ensure that the building design is an appropriate at appropriate level of the given building performance, whatever you want. So, according to that performance it should be there. Implement a building management plan that ensures that operating decision and tenants education are implemented in a satisfactory manner. So, first is the construction. In a building normally it starts from the owner, and then owners prepares a requirement brief for whatever it is, then actually the design, then actual realization of this design drawing board thing comes on to actual physical realization, but then after that is the maintenance and operation of the building. And must this management the maintenance building management plan, maintenance plus everything else, operation and management, maintenance and overall management of the building, that plan should come right in the beginning. So, right in the beginning this operating decisions, and if required the people who will be living or using that facility, they should be educated, and this should be right done in the beginning in a satisfactory manner. That provision should be there. So, all stages of building life cycle including demolition or deconstruction, that should be also taken into consideration. So, let us see the green building project delivery process. Once these aspects are all aspects are taken care of in terms of the design, drawing and things like that, and realization of the physical system, the concept of integration is very important in green building design, right. So, green building design uses integrated design process, IDP, as I mentioned, and the essence of integrating design is that building consists of interconnected or interdependent system. Now, that we know very well, building is the most complex of infrastructure, and it will have several interconnected systems, including trades of civil engineering, electrical, services of various kind, mechanical, and so on and so forth. And therefore, integrated design is important, right, and interconnected and interdependent system that is there. So, it is critical and consistent component in design and construction of green building. So, in green building this becomes even more, because there are several features which may not be there in conventional building. So, in case of green building design, the use of this kind of interconnected integrating the various interconnected interdependent system, that becomes very, very important, right, and it is critical in case of green building design system. So, the owner's representative or the person who represents the owner, that is number 1 is in the team. Then obviously, construction manager, obviously they will be hired, construction management or the construction team. Then you have architect, typically leads the design team and coordinates the activities. Then obviously, all the engineers, civil engineers, soil, land, and all regulatory aspect of construction project. These are the team that will do. So, it should actually a team, not piecemeal. For example, what happens is normally the architect is solely responsible. The owner is nowhere there, it is given to the architect. They make the plan and then possibly appoint a civil engineer or somebody structural engineer who does design, then a civil construction. But if the whole thing is put together in one go right in the beginning, in a larger team handles the whole situation, that it surely make a success. So, the team, it is a team effort of all those people, including owner or user, and this whole team, maybe the leadership might remain with the architect, but the whole team should be taken into right in the beginning, taken into confidence in order to make this kind of a project success. So, it is basically multidisciplinary project team, like consulting, for example, structural, mechanical, electricals, and on larger more complex project directly by the owner, depending upon the situation. So, management of green building design or strategies that should should involve this kind of strategies, which is slightly deviated from the conventional design processes, because it is more complex and you are trying to optimize everything, minimization of resource usage, natural resource usage, minimization of energy usage, minimization best indoor air quality, and so on and so forth. So, therefore, this is more complex than just doing an ordinary building when you are trying to do a green building design. Specialized consultants are adopted into the design as needed in the requirements of the project if required, right. For example, a fire consultant, I think normally they would be there in part of the thing, but you might have to involve them depending upon the situation. If it is a green building, functional green building, let us say a hospital building, then you might need some specialist, specific purposes, because avoid cross contamination, supply of various kind of life support system and so on. So, that would be that kind of scenario would be needed. So, usually such green buildings are high performance building, and basically the design process, site and design planning, these are the kind of stages, building energy use, indoor environment, material and product, water management, construction administration, operation and maintenance, and then commissioning. These are the features of features of design process for high performance building. So, you can see that first is obviously all the legal aspects, then the process of design, then site planning, building, look at the building energy use, indoor air quality, material product, water management, then of course, the construction administration and commissioning, and finally, operation and maintenance during the life of the structure, during the life of the structure, life of the building, right. Okay. So, high performance outcome necessitates a far more integrated team effort, team approach than the design process, and mark a departure from traditional practices in which emerging design are handed sequentially from architect to engineer and sub-consultant. So, that is the sequential thing is not there, it has to be whole team, right. So, traditionally what we do, we actually architect to engineer and then to subcontract consultants and so on and so forth. That should not be approach, all should sit together and possibly make the design so that high performance of the building can be achieved. Performance in terms of not only the structural performance we are talking of, performance, functional performance related to energy efficiency, thermal comfort, acoustic comfort, fire protection, services and possibly visual comfort and any other functional requirement, movement of people and so on and so forth, everything put together, and optimal use of resources. With optimal use of resources, minimization of waste, least embodied energy, least operational energy requirement and maintenance requirement and so on. So, that is what that can be ensured only through team operation. So, such integrated design process, that means you do all design in one go, integrated, right, inclusion of even contractors and operating staff and everything to include the likelihood of success, right. So, a team driven approach is considered to be a front loading, right, of expertise. The process should start typically begin with the consultant and owner leading a green design charter, you can say, with all stakeholders brainstorming session pertaining to approach that encourages collaboration in achieving high performance green goals for the new building while breaking down traditional adversarial roles. No adversaries, no fight, right, no competition. So, essentially all should work together, that is the idea. If you look at sustainable site selection, minimize the development of open space through selection of disturbed land. So, already existing, already this disturbed land, you select that. That is brownfield development rather than all greenfield development. That is the site selection. Or take a building, retrofit it to the current requirement of greenness, or it's that would be. So, green, new green areas you do not try to occupy, best is if you can change, retrofit it to the current requirement, and that is it. Energy implication of site selection, and then of course, shape, orientation of building and all these are important, as we have looked into. Energy efficiency envelope design, that would be very important. We did not look into envelope design in this course, but these are the issues: orientation, shape, they play a big role in energy efficiency. So, therefore, it should be related to the site selection. No erosion, soil erosion should be avoided, right. Right kind of landscaping practices, and if required stabilize the soil, no erosion should be there. Heat island effects should be minimized, which we have discussed from time to time. I know there are several of them we discussed actually, and minimal area around the building parameter, minimize habitat disturbances, you do not disturb the others around, all kind of habitats. Restore the health of degraded areas, if there is degraded area, put them back, increasing and improving the presence of healthy habitat for indigenous species, whatever is there around. Transportation solution should be integrated together with the site plan, that means how people should be moving. Possibly, if it is to be done with minimum energy, so they should be either walking or bicycle or similar sort of things. So, this should be integrated right in the planning stage itself, during the site selection itself when you are doing green building. Because as you shall see in the tools, site selection was one of the points where you have number of you had some weightages given. We have seen in many of the ratings or tools that is there for judgment of performance of green performance judgment. They have site selection is one of the things, and this is associated with this. So, the general intent of selecting a sustainable site is essentially to reduce environmental impacts. How do we do it? By avoiding inappropriate site and by selecting an appropriate location of the building. Location, orientation, everything put together. There should be, it should not be in the sensitive, it should not be, any sensitive element should not be included in it and should not be on restrictive land types. For example, do not encroach into a green area or anything of that kind or anything of that sort. Connectivity, density and community connectivity. You will, when you see the lead, you will see these requirements. Development of density seeks to construct, renovate on previously development land and community. Right. Community connectivity seeks to construct or renovate on previously developed land which is within the half mile of a residential area or neighborhood with an average density of 10 units per acre. Well, this will be an American sort of thing. In India, of course, the densities, population density is higher. And as I said, the half mile area concept comes from the original concepts of neighborhood actually proposed in USA in around 1920s, right, and half a mile, so which is within half a mile of a residential area or neighborhood. So, densities are also given, perhaps the density could be different in Indian scenario. So, essentially brownfield development it should be looking into. Basic intent is to protect green fields by developing an environmentally contaminated or damaged site, because I mean environmentally contaminated or damaged sites. What it means is that already there is a development, then that is considered as damaged, or you can so green areas should or green fields should remain as green field as much as possible, that is the idea. Transport, bicycle, impact of pollution and land development on the environment of reducing automobile use. Bicycle, storage and if required a changing room, low emitting and fuel efficient vehicles, sufficient parking capacity. Protect and restore habitat, maximize open space. Open space maximization is required for various purposes. One is the flow of air, lighting, fire protection, and built up area should be less so that your microclimatic changes are minimal. It does not store a lot of heat, because built up or constructed areas building tend to store the heat, and as you have seen in urban heat island scenario. So, this has to be there. Then design for stormwater, support natural water hydrology by increasing porosity of the soil, on-site infiltration and reducing pollution. That means water harvesting or something, allow water to percolate to the ground, right, and the quality control, water pollution, minimize water pollution by increasing pervious area, so that water there is no surface runoff, rather it recharges the ground and so on. So, as much as possible, that sort of the idea of green building design. Now, the lead name is coming because they are the ones originally they thought of, and we will discuss some of this. As I said, an example will be taken up later. So, heat island effect we have already discussed something, non-roof and roof applications we have seen. Minimize light passes from building site, reduce sky glow and increase night sky access. So, essentially such that the light can pass into the building, availability of the daylight and night sky access and so on should be there. Then in a commissioning process, all buildings system should perform interactively according to the design intent and owner's operational requirement. So, that is it's a synergetic approach to everything, right, and right from the project inception it will start, and it is a synergetic approach, right. So, all building systems should perform interactively and according to the requirement of the design. Basically, installation, calibration, performance of energy system, right, calibration of the energy system and their installation, they must meet the project requirement, basis of design and constructional document. So, that is during the time of commissioning, these are to be seen. And if there is later, then after commissioning, it is the commissioning of, if it is existing building, then what you do to do green situation. This is becoming increasingly prominent as an cost effective strategy for improving energy performance particularly. So, retrofit the building to the new energy requirement, that means you might change some of the envelope parameters, the orientation you can't change, shape you may not be able to change, but the envelope, some of the envelope parameters you might be able to change, envelope quality, material and things like that. Various other strategies could be there, new more efficient HVAC system and so on, those could be done. And start the process of commissioning right in the beginning together with the design process, together straight away during design process. I mean, think of commissioning right in the design stage itself, and additional activities on completion of the system performance verification. So, you verify the system and then once that is over, then additional activities would be. So, commissioning, first you start, look at that, and once you have checked the design performance, compliance with the design performance, then you start, once it is verified, then you start with the additional activities associated with this. Then of course, the cost management. For optimum results, integrate all projects activities, integrate all projects, all activities of the project. Management of the overall cost of the project, that is of course, the responsibility of project manager, but it is finally the owner, because cost is to the owner, and obviously, that has to be cost has to be looked into. So, you do not want to the minimization of the cost is an important feature. So, that has to be done. So, we get the best, we get best performance, but at the same time the cost has to be minimum. It is a big challenge, and therefore, you need all people to come together and integrate and design the system together rather than piecemeal with one being at loggerhead with the other or something of that kind. So, therefore, cost and value criteria, that has to be established right in the beginning, and that has to be maintained, right. And basically maintain the accounts, cash flow pattern, how it was supposed to be and how it is actually monitoring the cash flow pattern and so on, capital cost that has gone to the building and so on, that has to be done. So, in this context, identifying key elements and components to be included in the project, that is important. Defining project program from inception to completion, checking the orders and properly authorized, monitoring all expenditures if the cost is to be controlled, and full and proper control, and that all incurred costs are authorized. These are the kind of control that has to be looked into in case of cost control, key areas associated with cost control, right. And that is how you can achieve the green building design. So, that is overall strategy of green building design. I think with this we conclude our discussion. Thank you very much.